In this video, we are going to talk about prime numbers and what we can do with prime numbers. We will recall whole numbers and we will classify them as even numbers and odd numbers. And then we will also see how to classify them as prime numbers and composite numbers. Of course, we will recall what factors are and we will see the prime factors, and also we will see how to find prime numbers by using the sieve of Eratosthenes, an ancient Greek mathematician. Now let's recall what whole numbers are. Well, they are the numbers starting from 0, 1, 2, 3, 4, and it goes up to infinity. There are infinitely many whole numbers. Now we can classify them as even numbers and odd numbers, where the even numbers are the numbers ending with 0, 2, 4, 6, and 8, whereas odd numbers are the numbers ending with 1, 3, 5, 7, and 9. And as we said, we can classify whole numbers as prime numbers and composite numbers. Well, but before going through the definition of these two, let's discuss what factors are. Okay, suppose we have, say, 6, for example. Now, which two numbers will give me 6 when I multiply them? For example, 2 times 3, right? And also 1 times 6. Now here, the thing is that all these numbers 1, 2, 3, and 6 are called as the factors of 6. In other words, we can say that 6 is divisible by these numbers. Which numbers? All these factors, meaning 1, 2, 3, and 6. Well, this means there is no other number that you can divide 6. Or if you try, you will get a remainder. So it will not be divisible. So that's what we call factors. These are the factors of 6. For factors of, say, 8, for example, well, we have 2 times 4, and we have 1 times 8. So the factors are only or nothing but 1, 2, 4, and 8. These are the numbers which divide 8. So as you see, factors can change according to the number given. For 8, we have 1, 2, 4, and 8. For 6, we have only 1, 2, 3, and 6. Now let's go back to this classification of prime numbers and composite numbers. So when we say prime numbers and composite numbers, we are talking about a slight difference in their definitions. Now, first of all, think about this statement. All numbers are divisible by 1 and itself. Well, what does that mean? This means, say for example, if you have 10, all right, you can divide 10 by 1, which you will get 10, and you can divide 10 by itself, which you will get 1. So you can give many examples like that. Suppose you have 1292. Well, you can divide it by 1 and get that number itself. Or you can divide this number by itself and you can get 1. So actually all numbers can be divided by 1 and itself. The thing is that if you change this statement a little bit, like all numbers are divisible only by 1 and itself, then it will become the definition of prime numbers. So the true version is prime numbers are the numbers that has exactly two different factors, 1 and itself. And the composite numbers are the numbers that has more than two different factors. Now let's give an example. It will be like, for example, we used 6 before. So 6 was 2 times 3, or 6 was 1 times 6. And now here, 2, 3, and 6. Well, these are with 1 the factors of 6. But if 6 was only divisible by 1 and 6, then it would be prime. But no, it also has factors of 2 and 3. This makes 6 as a composite number. Whereas if we go for 7, well, you can only rewrite 1 times 7 for this, meaning 1 and 7 are the only factors of 7. You cannot find any whole number as factors of 7. So this feature makes 7 as prime. Prime numbers does not form a regular sequence, so we don't have a simple formula that gives us the prime numbers. Well, we have this old method, the sieve of Eratosthenes, which is named after the ancient Greek mathematician Eratosthenes, and it works quite well to define prime numbers. Now let's see how it works. The idea is quite simple. Actually, we will start from 1, checking the whole numbers, well, here for up to 60, and well, we will check them whether they satisfy the definition of prime numbers or not. So let's have the definition here. So prime numbers are the numbers that have exactly two different factors, 1 and itself. Okay, let's start with 1. Is 1 a prime number? Well, no, because, well, it has two factors, 1 and itself, which is 1, but they are not different. So 1 is not a prime number. How about 2? Well, 2 has two factors, but it only has 1 and 2 actually. So it satisfies the definition. So 2 has 1 and itself as a factor, and there is no other factor. So 2 is prime, and actually this is the only even prime. Can you think of why? Well, because if 2 is a prime number, all the multiples of 2 should be a composite number because they all will have the factor 2. They will be all divisible by 2. So, starting with 4, all these numbers, all the even numbers, will be composite numbers, so they are not prime numbers. Well, this is how the sieve works. So I just cancel all these even numbers, which they are not prime numbers. So it goes like that. If 2 is a prime number, its multiples are not prime. How about 3? Well, for 3, we have exactly two different factors, 1 and 3 itself. Well, how about 2? Well, 3 is not divisible by 2. So there is no other whole number that can divide 3. Hence, 3 is also a prime number. Well, if 3 is a prime number, then all the multiples of 3 should be composite because 3 is a factor of those numbers. So 3, 6, 9, 12, 15, 18, 21, 24, and so on. These are all multiples of 3, hence they are not prime numbers. So we just cancel these numbers from our list. Now, we already cancelled 4, so we skip that and we go to 5. For 5, well, it has only exactly two different numbers as factors, which is 1 and itself. 5. 2, 3, and 4, they are not dividing 5. So 5 is also a prime number. Well, this means that the multiples of 5 are not primes. Well, you see all the multiples in this column are cancelled. So I'm checking only the 5s. Well, 25, 35, and 55 in my list will be cancelled. Now, we skip 6. It's a composite number. We come to 7. 7 is also prime because it is only divisible by 1 and 7. And the other numbers in between cannot divide 7. So, the multiples of 7 should be composite, which I should cancel. Which are 14 cancel, 21 cancel, 28 cancel, 35 cancel, 42, 49, and 56, they are all cancelled. Now after that we have 11. You see the idea is the same. We have 13, we have 17, we have 19. These numbers are prime numbers. In our list, it was only up to 60, but you can make it longer if you'd like. Then this is how you use the sieve of Eratosthenes to find the prime numbers like that. So the numbers marked with a circle are primes.